Hi, I'm Manogna Menla Ramireddy. I want to explain the project I made which is a malware classification with AWS SageMaker. Uh, so, in this fast-paced digital world, where our lives are increasing reliant on technology, cybersecurity stands as paramount concern. The rise of malicious executable files poses, which is like exe files, poses significant risks to computer systems and networks, making their detection and classification imperative for maintaining security. Today, I'm excited to share with you my journey in developing a robust malware detection tool using AWS SageMaker, a powerful machine learning service offered by Amazon Web Services AWS. By leveraging machine learning techniques, especially a random forest binary classifier, which we use here, my tool provides a scalable and efficient solution for identifying malicious portable executable files, which is like PE files. So the project overview is my project is most of about cutting edge technology and cybersecurity principles aimed at addressing the growing threat posed by malicious software. I harness the capabilities of AWS SageMaker to build, train, and deploy my malware detection model. The comprehensive machine learning services that develop the development process ensures scalability, reliability, and efficiency. Additionally, I have developed a user-friendly web application interface, which I'm going to show in the video, and to enable seamless interaction with my API, enhancing accessibility and usability for end users. So, in this process, how I use the AWS SageMaker is the AWS SageMaker, which serves a cornerstone of my project, offering a unified platform for data processing, model training, and deployment. The processing, model training, and deployment are the three stages which I did to complete the project. The choice provides several advantages, including streamlined development process and reduced operational overhead with SageMaker's management infrastructure and auto-scaling capabilities also. I ensure optimal performance and cost efficiency, enabling seamless development and operation of my malware detection API. So the model, um, the malware detection model, at the core of my solution lies a random forest binary classifier, which is chosen for ability to handle high-dimensional data effectively and provide accurate classification results. Trained on a curated data set of binary features, which is extracted from PE files, my model demonstrates proficiency in distinguishing between malicious and benign executables. So the task approach. So here, I use several steps to approach my task. The first one is the data collection and pre-processing. My journey begins with gathering a diverse data set of labeled binary feature vectors, and I pre-processed this data to ensure consistency and quality, employing feature extraction techniques. I utilized libraries like pfile for that, and this step is crucial in preparing my data for effective model training. The model training, which is the other task, which is the other level to approach my task. I leverage my pre-processed data set to train a random forest classifier within AWS SageMaker. Through this tuning, I optimize model performance and enhance generalization capabilities, ensuring accurate classification of unseen data. For the model deployment, the trained model is deployed into database API on AWS SageMaker, providing a scalable and accessible endpoint for real-time malware detection, integrating with the AWS services, and seamless deployment and computational resources with the high availability and reliability. Web application development. To enhance the interaction and accessibility, I have developed a user-friendly website based on interface using this Flask framework. And this interface I'm going to show in the end how I did the the way it allows users to upload their exe files for analysis with the underlying system leverage and develop API for classification and providing intuition feedback. Performance. So, evaluation of my deployed API is essential to ensure its effectiveness and reliability. The test, which tests my API using diverse dataset comprising malware and benign exe files, computing performance metrics as accuracy. So, this this is how I made the I uploaded the exe files, which we can see here. This is the browse files. Here I uploaded the random exe file which is in my system earlier. I have this zoom I uploaded here, and for that I got this benign safe. And similarly, I tried for the malicious software also for the malware. I I drag and drop this file into this browse files, and I got that it is a malware. The malware is danger. So the project results. So here, the train malware detection, which I used a random forest classifier for accurately distinguishing between the malicious and benign PE files. And similarly, for deploying Cloud API, the model I used is the AWS SageMaker, offering a scalable and efficient API for real-time malware detection. And the web interface. This is the interface. um, a web interface application is developed providing a platform for users to upload and analyze their exe files. So, in conclusion, my journey in developing a cloud-based malware detection API using AWS SageMaker signifies a significant advancement in cybersecurity capabilities by leveraging machine learning techniques and cloud infrastructure. And my solution offers scalability and efficient malware detection capabilities, contributing to enhanced system security and threats mitigation effort. The successful deployment of API underscores the potential for leveraging cloud computing resources in cybersecurity applications, paving the way for the future enhancements and advancements in the field. And this is my README file. So it has the introduction table of contents, how to set up the thing, and how to clone the repository. This repository, the whole project I uploaded into the GitHub, and from there how to clone the repository and what dependencies I installed, and what I deployed on SageMaker and model usage, testing a benign file and a malware file, and what achievements that my project did. So, and contribution. So I want to discuss these topics in this README file. The project is ensuring the safety of digital devices by detecting harmful files. So I have developed this AWS SageMaker, a smart technology providing by AWS. This method called random forest binary classification to determine whether the file is safe or cloud or could potentially cause harm to the system. So my goal is to provide a reliable and scalable solution to identify dangerous files and protect computer systems from cyber threat. So the setup process here for the tool is straightforward and user-friendly. By following a few simple steps such as downloading files and installing necessary programs, anyone can get it up and running without any hassle. Once everything is set up, tool is ready to analyze files and help keep devices safe from harmful software. To ensure effectiveness of my tool, I conducted thoroughly testing. I provided it both with the harmful and malicious files, and to see how accurately it could distinguish between them. The results were impressive, demonstrating that my tool is highly reliable and capable of accurately identifying potential threats. With the solution in place, users can feel confident that their devices are protected from harmful files, providing peace of mind in an increasing digital world. So the requirements, the requirements I put a file for the requirements, which is this one. So here, the requirements are I used Boto 3. The version I used is 1.18.63. So I use this for AWS SDK for Python to interact with the AWS services with such as S3 for storing large data sets. Similarly, I used Pandas 1.3.3 version to essential for data manipulation and analysis. And I also use this to clean and pre-process the raw data which I have earlier. And I use the NumPy. NumPy is, as we all know, NumPy is a fundamental library for numerical computing in Python. So it has some basic array data structures and mathematical functions to to do all the computations which I require for the larger data sets. And similarly, I used scikit-learn, which the version is 0.24.2. This is a go-to library for every machine learning task, and it has various algorithms, and we can just use those patterns and we by predicting the model to uh, for the sale trends. And I use this requests. The version is 2.26.0, which is used for HTTP requests in Python, Python client. In this project, additional data is fetched from external APIs. So to enrich the analysis, I use this. And SciPy is a common library, is a similar library as NumPy, but it has some additional functions, additional computing things, and it has the statistical functions for hypothetical testing, hypothesis testing. So I use this to optimize and integrate the routines for advanced analytical tasks. Now I'm going to show, and now I'm going to show a web page which I have created to check whether the files we give, which .exe files, when we give them, it checks whether it's um, benign or malware. So for that, this is a PE client, this is a IPYMB file, and I'm going to show how I did this. So first of all, I'm importing the libraries with the command pip install boto3 file streamlit. And after running this, I ran this command to fetch the IP address. So I'm copying this IP address because this is the tunnel password for that website. That's a web page. So and in this cell, I have given the my credentials, my access key, my secret access key, and the session token of AWS here. And I've also given the yeah, yeah. So I have also given the S3 endpoint, the endpoint name here. So I'm gonna show that too. So yeah, this is the endpoint name, and I have given that too in the file. And here I'm running this Streamlit app command, and I'm gonna rerun this. So now this is the URL for the web page. Here I'm gonna paste the IP address which I have copied earlier because it's a tunnel password. And when I click on the submit, here you go, we get the web page. So when I browse a file or .exe file here, I'm gonna get a message whether it's a malware file or it's a benign file. So let's try that. Here, um, when I take a random .exe file, um, I'm taking Zoom file, which is .exe, and when I try and test it, I'm gonna get a message that's a benign safe. So it's not only telling that the .exe file is benign, it's also telling that it's a safe one. And similarly, I'm gonna try for the other .exe file. So yeah. So when I open this .exe file, let's just check this. Yeah. So now it's showing it the message that is a benign and safe. Now, similarly, we'll check for the a malware file whether it shows whether it's malware or not. Here, I'm checking a random file. Um, a random malware file. Yeah. So I'm taking this malware, and when I test it, it's showing it's a malware and it's a danger. It also shows that the .exe file is danger. Similarly, we'll check for the other exe file also. Here, I'm just testing. So we test for W64R now, and now I'm gonna test for W64. Yeah, it's dangerous. And let's just check for the other one also. W32. It shows dangerous. So when we this web page is helpful when we give a random .exe file to the system. It checks whether it's a safe one, it's a benign one, or a malware one. So this is my project, and from this, I think this is very useful for the user to check the exe files, and they can if they got to know that the exe file is dangerous, then they can save their system from these malicious malware files. Thank you so much for giving this opportunity.